Hello friends, this video on light, reflection and refraction part 13 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 12 before going ahead with part 13. So refraction of light is another beautiful phenomenon of light. We will see what happens in case of refraction of light in the next few slides. So let us now look at what is refraction of light. Till now we spoke about the reflection of light, which meant the bending or the bouncing back of light when it strikes a boundary between two media. So what is refraction now? It is the bending of light when it passes from one medium to another. So that means there is no bouncing back now. It says that light will pass from one medium to another, but the ray of light, instead of going straight, it will bend a little. So that is known as refraction of light. There are several examples around us where we see this phenomenon of refraction. For example, the first picture depicts a pencil dipped in a glass of water. You can try it on your own. Take a glass of water, put a pencil inside that water. What do you see? That the pencil appears little bent, as you can see here also. Right? Why does this happen? The pencil is not at all bent, right? It is a straight pencil. But due to the refraction of light, because here light rays are entering from one medium to another. One medium is air, the other medium is water. So when it enters from one medium to another, light rays bend. Now due to this bending of the light rays, the object appears little different than what it is actually. Similarly, if you look at this aquarium, you see that there is a fish which is visible in a different way. I mean, you see the actual position and the apparent position. I mean, the position where the fish actually is and the position where you are viewing the fish are different. That is again due to the phenomenon of refraction, because here also two medium are involved, air and water. Similarly, the rainbow which you see in the sky is also a result of refraction of light. Mostly you would have seen that a rainbow is observed after a rain. I mean, after rainfall, when one part of the sky is little sunny, whereas the other part is little cloudy, you generally see a rainbow. So this rainbow is also formed as a result of refraction. So we will discuss about the formation of rainbow in detail in one of the later slides. So for now, let us try to focus on the phenomenon of refraction. What actually happens in refraction? Now, similar to reflection, there are two laws of refraction as well, which has to be universally followed wherever refraction takes place. Now, in case of refraction, again, we have some of the terminologies. That is the incident ray, the ray which falls on the surface between the two media. In this case, let us suppose this is medium 1, this is medium 2. This is my incident ray and this is my refracted ray. Right? Because here if you see, the incident ray should have gone like this, but instead of that it gets slightly bent. So this becomes your refracted ray, and this normal is again the same thing, that is perpendicular to the surface. So the first law says that incident ray, refracted ray and normal to the interface at the point of incidence all lie on the same plane. So it is similar to the law of reflection, which says that the incident ray, reflected ray and normal should lie on the same plane. So this also says the same thing. The second law says that the ratio of sine of angle of incidence to sine of angle of refraction is a constant for a specific light of a specific color and for a specific pair of media. That means in this case, this is my angle of incidence, that is the angle which is formed between the incident ray and normal. Similarly, the angle formed between the normal and the refracted ray is known as angle of refraction. So here, theta 1 is angle of incidence and theta 2 is angle of refraction. So the second law says that sine of angle of incidence by sine of angle of refraction is equal to constant. Now, this ratio will remain constant only for a specific pair of media. For example, if this is air and this is water, So the value of sine theta 1 by sine theta 2 will remain same only for this pair. Now if you keep glass instead of water, the value of this ratio will change. So that means this is constant only for a specific light of a specific color. That means for a light of a specific wavelength, because if the color of the light changes, the wavelength also changes. So this is true only for a specific pair of media and for a specific wavelength of light. So this law is often known as the Snell's law. This is often known as the Snell's law. It is named after the scientist Snell. Okay. So now we will introduce a new term that is known as the refractive index. Now, what is refractive index of a medium? So what is this refractive index? Now, as I told that whenever light enters from one medium to another, the ray of light will bend. Now, there has to be some parameter to measure that how much bending of light will take place. There has to be some factors which will determine that okay, light will bend this much when it moves from this medium to this medium, it will move that much when it moves from this medium to this medium. So there has to be a measure of bending of light. So that is why this refractive index was introduced. It is the measure of bending of light during refraction. That means how much or to what extent is the ray of light bending when it enters from one medium to another medium. So how is it defined? It is defined as the ratio of the sine of angle of incidence to the sine of angle of refraction. Just now we saw in Snell's law that sine of angle of incidence to the sine of angle of refraction is constant. Now this constant is nothing but, this constant is defined as the refractive index. So we define this constant as N21. It is often denoted like this. That means this is refractive index of medium 2 with respect to medium 1. Let us suppose this is medium 1 and this is medium 2. This is the normal to the medium. This is the ray of light. This is I and this is R. So we say that sin I by sin R is equal to N21, that is refractive index of medium 2 with respect to medium 1. So this is how we define refractive index of a medium. It is also defined as the ratio of velocity of light of a given wavelength in empty space to the velocity in a medium. So that means we are comparing the velocity of light in a medium with respect to vacuum. So we also define refractive index of 2 with respect to 1 as c by v, where c is the velocity of light in vacuum and v is the velocity in some medium. Now there is another important relationship, that is refractive index of medium 2 with respect to 1 is equal to 1 divided by refractive index of 1 with respect to 2. So they are reciprocal of each other. Right? Refractive index of 2 with respect to 1 is equal to 1 upon refractive index of 1 with respect to 2. Now, from these definitions of refractive index, we can say that refractive index depends on nature of the medium. That is absolutely correct, because this velocity will depend upon the medium. If it is water, the velocity of light will be different. If it is glass, the velocity of light will again be different. So that means the value of refractive index depends or changes with the change in medium. It is independent of angle of incidence. Right? So nature of the medium is the only thing that governs the value of refractive index. It doesn't matter at what angle of incidence the incident ray falls on the surface between the two media, right? So the only parameter, that means refractive index is a unique for every medium. Every medium has a refractive index of its own. Now depending on the value of the refractive index, we can then judge the bending of light, how much the light will bend. Refractive index is the parameter which will tell us about the optical density of a medium. For example, whenever we talk of medium, we categorize them into two types. We say optically rarer medium and optically denser medium. So in this case, when we talk of density, we are not talking about mass density. We are talking about how dense is that medium to refract light. If the medium has very high refractive index, that means we say that it is optically denser medium. That means if light enters into that medium, the bending will be more. Similarly, if the value of the refractive index is very less, we say that the medium is a optically rarer medium, right? So value of refractive index also tells us about the nature of the medium. And the properties of a specific medium determines how much refraction will take place in that medium, or how much bending will take place in that medium. So whenever we talk about optically denser medium, it has higher refractive index. Optically rarer medium always have lower refractive index. Let us take this example. Let us suppose I have two medium 1 and medium 2. Now let us suppose if I say that N21, what is N21? Refractive index of medium 2 with respect to medium 1. If N21 is greater than 1, what does this mean? This means that refractive index of 2 with respect to 1 is greater than 1. This means that refractive index of 2 by refractive index of 1 is greater than 1, or it means refractive index of 2 is greater than refractive index of 1. This means that medium 2 is a denser medium and medium 1 is a rarer medium. So here denser and rarer means optically denser and optically rarer. Similarly, if we say that N21 is less than 1, this implies that refractive index of 2 is lesser than refractive index of 1. This means that 2 is a rarer medium and 1 is a denser medium. Now please make a note that here optical density is not related to mass density of the medium in any ways. Mass density talks about mass per unit volume. But when I talk about optical density, it means how dense or how much more dense or how much less dense is the medium to bend a ray of light. So if the refractive index is more, it will bend the light more. If the refractive index is less, it will bend the light less. Right? So now you understand the significance of refractive index and why it is called refractive index. It is called refractive index because it is an index which defines the extent of refraction. That is how much refraction will take place. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.